Okay, so these first questions are pulled from our quiz, and so it was the ones that were the most missed. So maybe 55% or less. I think some of them too even like got them wrong. Um, there was the calculator inactive and active, and I didn't see enough pattern to be able to just tell you what I think everybody did wrong. I'm not real sure, but for the conversation, if I was assuming when you had this, we got overwhelmed with which one was which. In this case, I just picked one, y equals negative 2x plus 5. It does have the equations on the page. And y equals a negative 2x, which is this guy. So that means you're comparing this line to this line. And the question was, how many solutions do they have? And in this case, those two never touch, so there's no solutions. And even if you didn't have the graph, hopefully you remembered or saw or noticed they have the same slope. And remember, same slope means they're parallel lines. And we know that parallel lines are two lines that never touch. And that applies here because your solutions are where they touch, where they cross. So to make both equations true, it has to be a coordinate that works for both. And honestly, if you think about it, it's the same thing plus 5. So there's no way that you could pick an x value to plug in and get the exact same y value out if you're adding 5 to one but not 5 to the other. Again, I'm hoping it's just because there was a lot going on. I believe one of the other questions was this equation and this equation. And so your intersection, it was how many solutions. And in that case, that's 1. None of these have multiple because they're all linear. So linear, the only reason you would have multiple is if they were graphed on top of each other. So you would have 2 equations. And most of those that you'll see like would be in standard form, which is kind of hard to read. Like that one is 12x minus 3y equals 3, I believe. And then the other one they give you will probably be in slope-intercept form. So y equals form. And so it'll look different. So the trick is that you understand that in standard form, if I was to convert this guy, so that would be like solve for y. So then I would have negative 3y equals 3 minus 12x divided by negative 3. Y equals a negative 1 plus 4x. So they may give you the standard form at the top and then also y equals 4x minus 1 and then ask how many solutions this system has. And since they are the same line, like exactly the same line, same slope, minus 1 at the end, all that good fun stuff, then they would have infinite number of solutions, infinite, because they're going to touch forever and ever and ever, like always, always, always. So they graph on top of each other. This was calculator inactive, but the graphs were given for you. Again, if it's calculator active, please go put these in. There was a lot of those that were missed, and I really don't know. It wasn't those of you who've been showing up to class regularly that was missing them. It was everyone else. So I'm not really sure how to make it any more clear that if you put them in the graph in Desmos, where they touch is the solution. And it is a coordinate. There's always an x and a y value. Now, this guy with no calculator, you're going to take y is x plus 5 and y is a negative 3x plus 17. And we're going to set them equal to each other because if one is and the other is, then they both are. And that may have sounded confusing like as far as conversationally, but so now we're going to solve for x. We have our line of great divide. And we need to get the x on one side and the constant or the number on the other side. I'm going to work to have a positive x, so I'm going to move my 3x. I'm going to add 3x to the right-hand side. Now, if you decided to move the x over, no big deal to which side. Just make sure you're paying attention to your positive negative. So positive 17, now positive 4x, and then 5. Again, we're trying to get 4x by itself. We need that x by itself. So I'm going to subtract 5 from both sides because that's the opposite of that positive 5. And now I have 12 equals 4x. And then from there, to get x by itself, what operation would I use? What would I do to solve for x from there forward? Yes. We're going to divide both sides by 4. Perfect. And then so x equals 3. But as I told you before in a previous class, x is 3 is great, but we're not done. Because remember, every solution is a coordinate. So we have the 3, but we need our y. You can plug it in either one. I'm going to plug it in the top one because that just looks easier to me. So 3 plus 5 is going to give me my y value, and that's going to give me 8. So the solution should be 3, 8. Any questions, guys, that I can answer for you guys on those two so far? Perfect. All right, what operations on the system of equations could be used to eliminate the x variable from the following system? This was a multiple choice. We're looking to eliminate x, so we're looking at these guys in the front, and we need to make them cross out. The choices you had on the multiple choice on this question, the first two were divide by, and it was divide by 2. I believe, no, I'm sorry, it was divide by 4, and it was divide by positive 2 for the first one, which you could do, but there's no reason, because if I divide by positive 2, I end up with a positive 1 and still have a positive 1. Remember, your goal is always to have them matching, like 2 and 2, but 1 being opposite. So same number, but opposite. So you could ultimately, if we are wanting to cross out y's, then we would multiply by a negative 2, and that would, the first equation, and that would make this a positive 2, and this one would become negative, and they would cross out. But in this case, we're looking to cross out our x variable. So we have a positive 2 over 1, just for the x. The easiest way would be to multiply the bottom equation, the second equation, by a negative 2, because that would then turn that into a negative 2x, and when you add down, 0x, which is gone. So that would cross it out. So the answer, when it was multiple choice, would be multiply the second equation by a negative 2. Not just a positive 2, because we need that negative since it was positive on the top. Is 6 negative 1 a solution? So for it to be a solution, it has to make the equation true. So it makes the equation a true statement. And what I mean by true is when I plug in my x and I plug in my y, it reads correctly. Whatever this y value is what I get on this other side. So it makes the equation true. Now remember, first value is x, second value is y. So we're going to plug it in. If this is calculator active, you could go graph it, and then you're looking to see if that coordinate is on that line. So our y value is a negative 1. Our x value is a 6. And I'm going to write it 6 over 1 because remember, when we multiply fractions, you're working right across the top, straight across the bottom. So 6 times a negative 4 is going to give me a negative 24 divided by 3 plus 7. So negative 24 divided by 3 is going to give me a negative 8 plus 7. And our y value is negative 1. If I owe you $8 and I pay you 7, is that negative 1? It is. So that means this coordinate does make that statement true, and it is a portion, it is a part of that line. So if I was to graph it in Desmos, if it was calculator active, you would see that line crossing through that positive 6, negative 1. Positive 6, negative 1. This is a great question. This was calculator active. It says, what is the sum, which means we're going to add, of the solution? And the solution, remember, is the intersection point. And it's always a coordinate, x value first. So 3, 2. If I add the solution together, so 3 plus 2, the answer should be 5. What is the sum of the solution to the system of equations? So there's one solution because it crossed one time. And it gave you your equations of your lines. It gave you all your information. All you need to know is the solution. So looking for the intersection and then add them together for that one. All right, this one turned out really poorly, and I don't know why. We've been reviewing these a lot, I feel like, but maybe somebody can shoot me a question. Let me know why this is so difficult. Maybe the decimals. So what is the difference, which means we're going to subtract, in the median, which is the middle number, of the two sets of data? Now it says round to the nearest 100, and they'll both be positive. So if we take our first set of data, so set 1, we want to put it in order if you don't use your calculator. So if we did this without a calculator, so $1.89 is the smallest, then $2.99, then $3.99, and then $7.49. And our median is going to be in the middle of that $2.99 and $3.99. Should be, I am going to use a calculator just so I don't mess up. So 345. I pushed the button wrong, I think. Nope, 349. So 349 is in the middle of this guy. Then we're going to do the same for the second one. Now, $2.87 is less than $2.99. Got rid of those. And then we have $3.28. And then $6.32. Again, your median is in the middle of that $2.99 and $3.28. So we're going to add that $2.99 to the $3.28 and divide by 2. And that's going to be $3.14. And then the difference in those two, we're going to subtract them. Looks like it should be 35. It's 35 cents. Perfect. And that's because it said, what is the difference in the median? So you had to put them in order to find your middle number. I'm assuming maybe some of us didn't put them in order. We just went and grabbed the middle numbers, if I was making my best guess. I'm not really sure. But that was a handful of the most missed quiz questions from last week. Overall, it was a pretty good quiz, it looked like. I am going to the packet I sent you guys. There was some EOC review on the first couple pages. Just a couple. Yeah, we'll do them. We'll knock these out. They won't be too hard. So a system equation is shown which statement is true about the solution to the system. So looking at this in the way it is, one is in slope-intercept form, and one is in standard form. If it's calculator active, again, you can put them both in exactly the way you see them in Desmos and see where they cross or if they cross. In this case, looking at that first one, we know we have a slope of 2, a positive 2, because that's y equals mx plus b. It's just slightly flipped. So 2x plus, our 6 is our b. So our slope is 2. And the reason I'm discussing slope is because it talks about infinitely many solutions with parallel lines, same line, no solution because of a parallel line, no solution because it's the same line. The slope is going to be where you could tell this if you were not graphing it. So then we want to solve this guy for y. And we'll subtract 4x from both sides. And that gives me a negative 2y equals 6 minus 4x. Divide by negative 2 because we want y by itself. And y equals a negative 3 plus 2x. Again, a little out of order. So if you want to write it in slope-intercept perfect form, mx plus b, or in this case, that minus 3. So looking at this equation to the equation above, if we look at our slopes, what do we know about their slopes? Yeah, they're the same. Perfect. So they're the same. And as soon as we see same slope, then you should think what? What are we training ourselves to think? As soon as you see same slope, you should think what kind of line? Parallel lines. Perfect. So parallel lines. And we know the definition of parallel lines means that they are never going to touch, right? So never touch. Infinitely many solutions, because they're parallel, does not make sense because they are never going to touch. Infinite means they touch every single dot's going to be the same. So A's off. Infinitely many solutions because the lines are the same. That would be a true statement. It just doesn't apply here. So infinitely many solutions mean the lines are the exact same line. In this case, our y-intercepts are different, so they just slid up the graph or down the graph. There are no solutions because the lines are parallel, and parallel lines never touch. So that's exactly what our answer should be. If you know they're parallel, they're never going to touch, and the solutions are always where the lines touch. All right, Sakai saves money each week for a vacation. The expression 85 plus 20x represents the amount of money in dollars Sakai has saved after X weeks. What does the constant term represent? So this is y equals 20x plus 85. The initial amount Sakari saved for vacation, the total amount Sakari has saved for vacation, the amount Sakari still needs to save for vacation, or the number of weeks Sakari has been saving for vacation. So again, we're looking at our constant term, which means there's no x there. So that'll be this guy, constant. So that's our y equals mx plus b. Constant term is going to be b. what do we know about this guy? What does that tell us? Is it initial amount, total amount, the amount that still needs to be, or number of weeks? Yes. So remember, another word for this is slope-intercept form. So all our words. So y-intercept is also your initial amount, your starting amount, your constant. So initial amount, sorry, I left off a word. Constant, that's going to be 85. So just alone, if you read nothing else, initial amount is the flag word right here that makes A our final answer. The total amount she has saved for vacation is going to be Y. So this is our total. Our output when we're done. The number of weeks is going to be X, not 20, but X, because remember, X and 20 are different because that's MX and B, and they each have a different part. So X is your input, so that's how long he's going to save, and then your output's going to be the total amount of money he's going to save. So the money in dollars, that means this is dollars, dollars, dollars. X will be your weeks, as it says here. The amount he needs to save at vacation, maybe arguably could have been a Y value if they'd given it to you. That one's maybe a little bit of a push and a dig for that answer. But your constant is always the initial amount. Your y-intercept is where you started, wherever they're going to start tracking this data, or when you start graphing a line. All right, graph below. We have a graph. Which line is parallel to the line on the graph? Now, you can do this a couple different ways. Number one, put these in your Desmos and look for the slope. But for here, we got a y-intercept of 4. We're going to write the equation of this line. It is a negative line because it's decreasing. We're looking for good intersections, which would be all of these guys. So that's down 2 over 1, down 2 over 1. Or if you wanted to go up 2, left 1, up 2, left 1, that just means we definitely have a negative slope. So we're going to write it in y equals mx plus b form. Our b value is a positive 4. Our slope is 2 over 1. It's negative. And as we write it rather than run, we know hopefully at this point this is going to be a 2x plus 4, negative 2x plus 4, not negative 2 over 1, because whole numbers have that imaginary 1 underneath them. But it's not very rarely ever shown that way when we write the equation. So we are looking for this equation down here with the same slope. So the only number that actually matters for it to be parallel is that negative 2. The same slope is negative 2, and I boxed in x, which is probably misleading because remember, x is input, not the slope. But mx, we want a negative 2x. So if we start looking at these, I know I want y by itself. If I move that negative 2x, I'm going to add 2x. That's not the same as negative, so we're done. I would stop even playing with it at that point. This one, we're going to move our x, and that's going to be negative 2y equals 6 minus x, divide by negative 2 all the way across. We're going to have y equals a negative 3 plus 1/2 x. Now, 1/2 x is not the same, but what kind of line is the equation with a 1/2 x relative to our negative 2? So thinking negative 2 to a positive 1/2. What kind of line is that? What relationship do those two lines have? Are they parallel or perpendicular or no relationship? So they're going to be perpendicular because they have opposite and reciprocal slopes. So opposite being this one's positive, this one was negative, and reciprocal is the flip. So it went from negative to positive and then flipped over. So B is not parallel because we're looking for parallel. Looking at C, we're going to move that 4x over. We're going to subtract 4x from both sides. So I end up with negative 2y equals 4 minus 4x. We need to get the 2 off the y. So we're going to divide by negative 2. And y equals a negative 2 plus 2x. Plus 2x. So we're close, but not quite, because that plus 2x is not the same as a negative 2x. So going for the last one. Hopefully it's a good question. We're going to move the 4x. So 2y equals 10 minus 4x. And you get the 2 off the y still. And that's 2 times y. So we're going to divide by 2. And now we end up with 5. Y equals 5 minus 2x. And there's our same slope as here. So D is the answer to that question. 4x plus 2y equals 10 is a line parallel to the line in the graph. All right, so inequalities, systems of inequalities. Very similar to systems of linear equations, except you have a little more wiggle room because the inequality just means that y is less than. So there's going to be lots more answers. It's an entire chunk. We talked about it last week, right, or week before last, right before spring break. It's a big shading of the graph instead of just a line or just a dot. So in this case, if you did not have a calculator and you needed to solve this, you would need to plug these in, and you're looking for which coordinate makes both of them true. So remember, the first number is your x value, the second number is your y value. So if I'm working on my first one here, my y value is a negative 2, my x value is a negative 10. And then is negative 2 less than negative 10 minus 7? Negative 2 less than a negative 17. And in that case, no, because negative 2 is getting closer to 0. So that's no good. So this one's out. Moving right along. We'll go to positive 10, positive 7. And you can put it in either one. I'm staying away from the fraction for the moment. But either one. So positive 10, positive 7. X is 7. So positive 10 less than 7 minus 7. 7 minus 7 is 0. Is a positive 10 less than 0? Nope. So that guy's gone as well. Working down your next set. Negative 5, 2. So if we go to negative 5, 2. And I'm going to keep using the same equation. So negative 5. Ooh! Mine's wrong. I did that wrong. Our y value is 7. Our x value is 10. 10 minus 7 is still 3, though. 7 is still not less than 3. 7 is not less than 3. Now going back. So 2 less than a negative 5 minus 7 is 2 less than a negative 12. In that case, nope, no good. Last but not least, negative 2. So negative 2 less than 10 minus 7 is negative 2 less than 3. Owing someone $2 is indeed less than having $3. So your answer to this equation, and you don't even have to do the second one, they kind of set you up for this guy, is 10 negative 2. It is going to fall on that. Also, if this is calculator active, and I'm just showing you the way to do this, if you did not have a calculator, because like I said, from looking at people's quiz, I'm a little concerned that maybe we're overly, I'm not really sure what happened, but conversation. So remember, we can put these into Desmos as well. So y is less than x minus 7, and it graphs it. And then our second one was y is less than, whoops, that's not less than 1/5 x, and I don't need this, it seems to like it, 1/5 x minus 2. And so remember, the solutions to the system are going to be in the overlap over here. And our choices were a negative 10, negative 2. So if I go over here to negative 10, negative 2, that's here. We can put that in over here if we want to really discuss it. Negative 10, negative 2. That green dot is definitely not in the overlap. It's in none of the shaded regions, so that's definitely not one of them. Then we had negative 5, positive 2. Again, not in a shaded area, so that's not a thing. Then 10, 7. And that as well. We go look over here at 10, 7, not in the shaded area. And last but not least, the one that algebraically was true, we found to be true, but just to double check it. Positive 10, negative 2, you see the red dot is in what I would call like the purple. So it's not just in the red, it's not just in the blue, it's in the overlap. And that's how systems of inequalities work. You're looking for what makes it both equations true, which would be any point in the overlap. So then if I say that again, so you're looking for the point that is within the overlap, so makes both shaded equations true. Is 12,2 a solution to this system? Is positive 12,2 a solution to this system? Ryder, is positive 12, positive 2 a solution to this system? Okay, let's see. Whoa, where did I just click? I don't even know what I clicked. Whoops, 12, 2. Is that in the shaded area of the two? Maddie, what do you think? Is that in both shaded area or just one equation shaded area? It's only in one, right? And if we were just talking about one equation, then that'd be good if we were talking about our red equation. But because it is a system, it has to be in both. So the only solutions would be the ones that are down here in all of this. Like I said, I'm calling it purple. It's kind of a weak looking purple. It looks like mud. But down here. So 12, negative 2 would be a solution because that's in the overlap. So 12, negative 2 is a solution because it's in the overlap. So a positive 2 was up here, so only a solution to one equation, not both. As long as we're doing systems, it has to be true for both. Algebraically, we were only checking one equation because it wasn't even getting the first one to be a true statement. So back over here, we have another one of those. So we have 2. Also, just a great call out when you're graphing these. Remember, equal to is a solid line, so that means a solution can fall on the line. And then the lack of equal to, so just a less than or greater than, has to be in the entire shaded region, but not on the line because that's just a parameter, not an actual you can stand on it spot. So we have double fractions. I'm going to go with 1/2 because I feel like 1/2 is one I could do a little easier in my head. I'm going to take our first one and check it. So x is a negative 8, so 1/2 of a negative 8 plus 5 is greater than a negative 4. So 1/2 of negative 8, if I have $8 and I'm splitting it into 2, means this is going to be, what's 1/2 of negative 8? Yes, so negative 4 is greater than negative 4 plus 5. So negative 4 is less than, I think I just said greater than, sorry, positive 1. Negative 4 is indeed less than a positive 1. So we can go check the other equation as well if we want to, or we can keep moving down the line. Up to you. Let's go ahead and check the other equation because that means we can practice some multiplication of fractions. So our x value is a negative 8. Again, 3 over 2 times a negative 8 plus 4 greater than, negative 4 is greater than or equal to. 3 times a negative 8, what's 3 times a negative 8? Ooh, super close. 3 times negative 8, so 8 times 8 times 8, but it's a negative. So it'll give you 24 divided by 2 plus 4. So negative 24 divided by 2 will be a negative 12 plus 4. A negative 4 is greater than or equal to a negative 8. In that case, negative 4 is greater than a negative 8 because it's getting closer to 0, and that's where we start getting good money. So far, this guy looks good. So that should be our answer. Again, we can go plug these into Desmos and double check, and then I'll plug in these points, and we can look at those and see how they add into it. So let's get rid of all these. So y is less than, the second equation was 1/2 x plus 5. Whoops, that's not the right x. Nope. There we go. And then we'll get over here where we can see some of it. And then our first equation was y is greater than or equal to, and you would find that in our keyboard here, greater than or equal to, whoops, I'm in the wrong one now. Sorry, guys. Greater than or equal to 3/2x, 3/2. And then it was plus 4. So our choice that we think should have worked is -8, -4. -8, -4. Whoa. Is that purple dot in the overlap? Yep, so we're good. And just for the sake of checking to make sure all the rest of them did not work, so -8, -2. Oh, this one, I just messed up. The question, I didn't even read it. It says which is not a solution. So all of these but one are going to be a solution. So -12, -6. That's in our overlap as well. 8, 0. Now 8, 0 is over here. Why is this not a solution to the system of equations? Why is this not a solution to the system? It's not in the overlap. Right, exactly. Perfect. So going back, I jumped too fast. The print's really bad. Hard for me to read. Uh-oh. There's nothing for you to see now. Sorry. It said not be a solution, so I fell for the trick. So all three of these were solutions because they were in the overlap. This is not a solution because it was not in the overlap. It was only a solution to one of them. Now, just again as a call out to make sure in case we have it without a calculator for whatever reason, if we're looking at each one of these. So y is greater than and -1/2 x plus 6. They graph them, but you have to tell which one is which. It does have dashed lines because neither one of those equations have an equal to it. That constant, that plus 6, means it's going to cross the y-axis at plus 6. So then we know this is our first equation. And it says y is greater than. So if I'm looking at my y-axis, which way are the numbers getting larger? Up on the y-axis or down? Where do you find bigger numbers for y? Traveling down or traveling up? Traveling up, right? So then for this one, y is greater than, we're going to go to that line and shade towards our up arrow. So it should be shaded here. Then for our other one, it has a y-intercept of +3, which is right here. So we know this is the right one there. Or maybe you even notice this is a negative slope. This is a positive slope. Our blue line was going down. Our orange line is going up. It says y is greater than. So again, we just said the greater than is going up. So we know we're going this way. And it's a system. So hopefully we're getting the hang of it. And the system solution is in the overlap. And the overlap in this case is all of this right here. That's not really good to see the difference, but this area is our overlap. Maybe that works better. So which one of these coordinates is indeed a solution? So -10, +6. Is that a solution? +8, 5. So 8, 1, 2, 3, 4, 5. Is +8, 5 a solution? Nope. +6, -1. Is that a solution? And then 3, 10 up here in the overlap. So there we go. Perfect. All right, so next one, we have a negative line and a positive line. Our negative line is going down this way. It also has a y-intercept at a +3, which is this guy here. So we have this one. y is less than, so if we're looking at our up and down on our y-axis, less than would be going up or down. Where are the values smaller on the y-axis, up or down? Down here, perfect. So then we're going to take that line, the blue line I just showed you, we recognized it as the line for that equation, and its y is less than, so we're going to shade towards that direction from that line. So we draw a line, and then we want to make sure whatever side includes that down arrow. And then y is less than, looking at that positive 2, which would be here, positive line. So we're looking at this line, again, dash, which means nothing that falls on it is actually a solution. And then again is y is less than. So we're going to go from our line and shade towards that down arrow, because that's where the less than is, and then shade in everything on that side of the line. So again, our solutions are the overlap. So I'm going to be quiet for a minute and see if you guys can figure out which one is the solution. 0, -5, -6, 2, -2, 6, or 9, 3. Yep, 0, -5 is the solution. Good. Why is 0, -5 the solution? Yes, because it's in the overlap. All right, beautiful.